We have three survival strategies or patterns of survival. And so the first one we're going to talk about is type 1. And this corresponds most closely to the K-selected species. And so these are our larger animals. They have fewer offspring. And so you can see here if age is on the x-axis and the number of survivors is on the y, the number of organisms that survive in the type 1 species that are born tend to survive longer, and they live their full lives and die off as they get older. And so we can look at the opposite end of the spectrum, and this is most closely to our S-selected species. This is our type 3 survivorship strategy. And so we can see of all of the organisms that are type 3, they're going to have high numbers of die-off early on, but those that survive tend to live their longer life and then die off at an older age. And so what we have here is somewhere in the middle, our type 2. And so this examples of this would be like squirrels and corals. They have a relatively constant decline in survival throughout their years, throughout their life. So you can see that it is a straight line, so it's a constant trend. And so we look at populations, and we have to understand that populations can be separated. We think about our mountaintop, our mountain or island biogeography that we've looked at in the past. And we've said that as populations are larger or more connected, they have a better survivorship. They are more likely to survive because they are more genetically biodiverse. And so we have, in New Hampshire, actually we have mountain lions, also known as pumas or cougars, and they live in heavily wooded mountaintops, which sometimes are separated by developed areas. And so you have these islands of wooded mountaintops, but sometimes they have corridors. So if this is one heavily wooded mountaintop area, and this is another heavily wooded mountaintop area, there might be a small slice of land or small strip of land that allows the two populations to connect. And so if these populations, while they are distinct, but they can still connect, they can still interbreed, we call these metapopulations. And so in New Hampshire, we have these metapopulations of mountain lions. They're spotted all of the time by people's cameras, and their scat is found, and so are their prints. However, they it would be expensive for us to protect them, for the Fish and Wildlife to protect them. So we keep on our understanding that there are not any mountain lions in New Hampshire, but there are in fact these corridors that create metapopulations. And so these metapopulations increase the gene pool or the diversity of the gene pool, because inbreeding is more likely to occur in small populations. And as we've discussed in the past, you see more diseases or recessive diseases will display themselves. And also small populations are more susceptible to catastrophes. And so therefore, if you have a small population of 2 red beetles, 5 brown beetles, and 6 blue beetles, if somebody accidentally stepped on the beetles and they stepped on the 2 red beetles, that would have a very distinct effect on our small population. But if we have thousands of red, brown, and blue beetles, forget the colors, if you step on a couple of those beetles, it's going to have a much smaller effect. And that's our concept of genetic drift. And then also genetic variation and recombination offers more adaptations or survivability to a population. The populations that can adapt are more likely to overcome obstacles in the future. And so we see that many of these populations that are meta-populations or have corridors have the patchy or clumped distribution, just as we spoke about in Module 18, our clumped distribution. across the landscape. An example of this would be our monarch butterflies. They have great migratory patterns where they cross an entire continent here, go down to South America, and then come all the way back up. And so they have to have many spots where they can stop. And so these corridors are very important, as well as with frogs and wetlands. So if you have two wetlands close by, frogs can migrate from one wetland to the other, and that will then increase the genetic variability in both of those ponds, or both of those wetlands. And so those are corridors, and they're becoming increasingly more important. And so therefore something that people that are in fish and wildlife have to take into consideration and when we are discussing what land to protect. And that is it for Module 19. Have a great day.